Howdy, howdy, this is Mr. Potter. In this series of videos, we're going to be talking about how to program in the C++ language, and I'm going to be assuming that you've already gone through our Java course, and in that I'm going to be doing a lot of comparing and contrasting what we learned in Java versus how it's different in the C++. C++ is a much more robust language. It's a lot more developed, and it actually deals a lot more with direct access to the memory. Now, a lot of schools won't allow you to install a C++ compiler on their systems, or won't allow you to run C++ executables for that very reason. It is a very powerful language. And so what we're going to be using in this course is we're going to be using an online IDE. So the one that I've chosen to use is Cloud9. The website's c9.io. I've also used a couple of others like coding.com, and I'm going to put some links down in the description if you choose to use those. What I'm going to go ahead and do is I'm going to set up an account on here. So I'm going to hit sign in. Actually, I need to sign up. That's what I need to do. Let's click on sign up. And we're going to create a username. So I'm going to be mistapotta OHS, and I'm going to set up my email, mistapotta@gmail.com, mistapotta@gmail.com. I'm going to spell my email right, which is always helpful. I'm going to choose a password. I don't want to receive the monthly letter. I am not a robot, and I'm going to create my free account. So I do this, it goes through everything, and it's wanting me to go ahead and get my verification email. So I'm going to go to my email, and hopefully they've sent me one. Got an update. So if I go to Cloud9, here's my welcome to Cloud9 and my access link. And so this activates my account. So now that I've got an active account, the second thing that I need to do after I re-sign in is I'm going to need to set up a workspace. So I've got my mistapotta@gmail.com, I've got my password. I don't want to have to type it in over and over again. And so this takes us to our workspace. So I want to actually create a new workspace. And in creating a new workspace, I want to make sure that it's adaptable for C++. So there's some things that we're going to have to set up. I'll talk about how to set those up in just a moment. So now that I've got it to actually create a new workspace, I'm going to type in my workspace name, and this is our CS3 workspace. I can't put any spaces in here, and you may want to be careful if you're trying to put some more personal things in there. I mean, not personal things, but if you're trying to put some All right, so now we've got it where it's asking us about our new workspace. I'm going to call this my CS3 workspace. You can't put spaces in here, and I certainly would be careful about putting special symbols such as pluses or underscores in here. If you try and stay alphanumeric, it should be fine. Quick description, this can have spaces, so this is going to be our C++ test bed. This is where we're going to be doing all of our C++ test code. And if you try and make this private, you may have to pay for it. Just please be careful with that. You can make it public, but then everyone will be able to see your code, so that may not be for you as well. But I do need to make sure that I click this tab down here and make sure that C++ is the template that we're going to be using. And then I choose Create Workspace. Okay, so see, it told me a workspace can only have lowercase letters, numbers, underscores, and dashes. So CS3 with lowercase. So we'll set that up. All right, so now we are loading our workspace, and we should see it come up pretty straightforward. And this is our desktop IDE. So there are three regions I really want to talk about. The first region is down here. This is where we're actually going to be typing in commands. This is going to be where we type in the command to compile as well as to do some other things. This is a full Linux suite here, so I can actually go in here and type ls, which is the command to list files. And when I do that, it's going to list all the files in the directory. The second thing I noticed is that these files here are the same files that are listed up here. So here I've got a file viewer, and so I can double click on any of these to open them up, and they'll open up in this third panel up here. So I'm going to do a couple of things real quick before we start our program. First thing I'm going to do is I'm going to close all these windows because I don't want to have anything open up here. The second thing I want to do is I really want to change the font size so we can see things a little bit bigger. So let me go ahead and do the font size down here first. And it's not going to let me do that. So the next thing I'm going to do is we're going to create our first program. So I'm going to hit the plus here, create a new file, and we're going to go ahead and save this as, and we're going to call this hello world.cpp. So this is going to be our hello world. Notice that we're saving in the root directory. So it's going to be saved in the CS3 folder that we set up. So now we are ready to type it. As we type the program, we're going to see it color code certain things. The first thing I want to talk about when we do this is in Java we had import statements, and these allowed us to import other classes. In C++, we don't necessarily import classes. What we import are packages. And we're not going to use import. We're actually going to use the hashtag include command. And this is going to include whatever package I have. Now, system packages will be enclosed through these angle brackets, whereas anything that's user defined is going to be in quotation marks. So I'm going to include this package, IOStream. And what this is going to do is allow us to use input and output, which of course our Hello World program definitely should use output. So this is our first thing that we're going to do in our program. The next thing I'm going to do is mainly a convenience for us. I'm going to type using namespace std semicolon. And the reason I'm doing this is because in our input-output stream, we have a standard namespace. So the methods that we're going to be using, the functions that we're going to be using, all come from the std, or the standard package. But I don't want to have to type std : and whatever the command is, because that certainly is a lot of overhead. This keeps me from having to specify the scope of the command. So all I have to do is just type the command. So if I had used something like this in Java, it would have been a situation where I wouldn't have had to use system. I would just have to say out.println. And that's really going to help us here. This is a command that I want to end with a semicolon. The include statement is not. So now I'm ready to start my main method. Notice that we're not in a class, so I don't have to specify if it's a static method or not. I don't have to specify if it's public or not. All I have to do is specify the return type, and it's not void, it's int. And the reason that our main is an int method, or an int function, is because most C++ programs, when they terminate, they give a value to whatever process called them. So if a program chose to run another program, it may be waiting on the result to see if the program executed correctly or if it ended abruptly. Normally when we execute correctly, we're going to just return the value of 0. And when we return a non-zero value, that's when something horrible has happened, like a file not found error happened, or an undefined variable happened, or something like that, where our program crashes in a runtime situation. So our return type is going to be int, and that's because we need that information to process should another process be running this. So we're going to go ahead and open up our braces and enter our scope. So this is our first program, so I'm going to put a comment in here, and of course we do comments exactly the same way that we did in Java. I can use the double slashes here and say my first program, or I can do the /* and then everything between here, and then */, so I can do block comments the same way, everything. But now I'm ready for my actual command. So our first command that we're going to learn is console output. But it's much simpler than that. It's just cout. So cout is our first command. This is part of the standard namespace. So if I wanted to run this without using namespace std, I would have had to have typed std : cout to make sure that I'm actually in that namespace. But because I'm using namespace std, because I've got line 3 up here, all I have to do is cout. The thing to remember is that cout is not a method. There is not parentheses. There are not parameters to this. This actually is an output stream. This outputs directly to the console. So in order to direct things into the stream, I have to use what we call insertion operators. Now, our insertion operators look like two less than symbols. And notice they're slightly different color. They have a very specific interpretation in C++. And whatever follows this is going to be directed to the console output. So I'm going to say, hello world. So this string literal, hello world, is going to be directed to console output. Now, I could put a \n here because that is an escape character. That's perfectly acceptable to force it to do a new line, but our standard namespace also has something else that we can put into the output stream, and that is ENDL. And this ENDL is essentially our end line. And what's nice about this is that I don't have to worry about whatever system I'm on. You may notice that I'm currently running on a Windows system, and so some systems have \n for a new line, some systems have \r for a new line, some systems actually have a combination of the two. If you're running Windows or Linux or a Mac, you actually have 3 different interpretations of this. But if I use ENDL, then the program knows, hey, this person wants a physical new line. Everything that follows should be on a subsequent line. And I don't have to worry, is this a program for a Mac? Is this a program for Windows? Is this a program for Linux? C++ takes care of this for me. Now, the last thing I want to do for this program is, because we are returning an int type, I actually need to return a value. And if I've reached this point in my program, everything has worked exactly how I planned it to work. So there aren't really any errors, and I want to report that to whoever called us. So I'm going to say return 0. And so this allows us to return that, hey, everything was fine, to whatever method calls us. Now, we're going to be calling this from the command line in just a moment, so we're not actually going to see the 0. The operating system would see the 0, but we won't. So I'm going to go ahead and file save. Remember, you can just do Control S to save if you wanted to, but this saves everything, and it gives us confirmation that all changes have been saved. So now what I want to do is I want to talk about how to compile this. So in order to compile this, the reason that we're using this online IDE is because most labs, most schools won't allow you to install a C++ compiler or to run C++ executables. And the primary reason is that C++ executables deal very intensively with memory. We are directly accessing memory. And we're going to talk about some of the things that can happen, good and bad, in this idea of directly accessing the memory. For now, though, we're doing this in this enclosed environment. This is actually a virtual Ubuntu Linux distribution that we have running. And we're just going to go ahead and compile this. So in order to compile this, I'm using the GNU compiler. So this is going to be G++. That's the command to compile. I'm going to have my source code, which is hello world.cpp. And then I'm going to have a flag. It's an output flag, so -o. And the reason I've got this is because if I don't put this, it's going to store the output in a file called a.out. That's just the default file that it's going to store it as. And I don't necessarily want it there. I want it in a much more descriptive name. So I'm going to type the output file name that I want, which is hello world.exe. And I know this is anathema to anyone who's programmed in a Linux environment. You're like, why are you calling this an exe? And I'm simply using the file extension, the 3-letter file extension that I'm used to from working in Windows and Mac, to specify that this is an executable file, that this file will have the executable flag set to it. Normally in a Linux environment, you wouldn't see any extension here, you would just see hello world. But for our purposes in this class, I'm going to, by convention, end our executable files with .exe. That way when I look up here, I'll be able to see, oh, anything with a .exe, that's an executable file. So I'm going to go ahead and do that, and if it has no errors, we're going to not see anything. Notice that hello world.exe showed up here. If I double click, it will open up in this window here, and I'm going to see a lot of gobbledygook, which I really don't want to see. This is a binary file as opposed to a text file like CPP is. So I have this executable, but if I just try and type hello world.exe, it's going to tell me that it cannot find the command. The thing is, hello world is not a command. Hello world.exe is an executable file. And I actually want to run this file. So I have to tell it precisely where to find this file. And the way I do that is I use // in other words, telling it to look in the current directory, / hello world.exe. And when I do that, I'm going to see my command hello world down here, and then it's ready for more input. So what we've done today is we've talked about how to write our first C++ file. We've talked about several of the components that we're going to see that are going to be mainstays that we're going to see repeatedly. This idea of an include, how to use the namespace, the fact that our int main is going to be an int. It's not going to be public. We're not going to write static, and that we're going to be returning 0 when we've completed it. We've also learned one command today. We've learned the console output command, cout, and we've learned how to use insertion operators to direct output through to the console. And we've also learned how to actually physically compile a program using the GNU C++ compiler G++. So what we're going to do throughout the scope of this course is we're going to learn C++ as well as we learned Java. Since we've already learned a lot of the essential components of Java, I'm not going to spend that long going through it. It's actually going to be a fairly short burst of going through this is C++. But we're also going to be talking about some of the subtle nuances in C++. After we've got a firm foundation of how do we write a C++ program and how do we get it to do the things that we knew how to do in Java, we're going to go into a more in-depth analysis of data structures. So we're going to be talking about stacks and queues and linked lists, the idea of first in, first out versus first in, last out, how to dynamically allocate memory. We're also going to be talking a lot about big O notations. So we're going to be talking about programming efficiently, not just efficient use of memory, but an efficient use of time. And we're also going to talk about a lot of time versus memory comparisons in this class. So over the scope of the next 8 or 9 months, we're going to be going into a lot of depth into C++, and I hope you enjoy the journey. So once again, this is Mr. Potter. Thank you for watching. Have a great day.